In a distributed system with 5 servers, how do they all agree on the same thing? This is the problem Raft solves. Distributed consensus. Its answer is surprisingly intuitive. Let the servers vote. A Raft cluster consists of an odd number of servers, typically 3 or 5. One is elected leader to serve clients. The rest are followers that passively replicate data from the leader. Every node holds a complete copy of the data. Clients talk only to the leader. All writes are processed by the leader and broadcast to followers to keep every node consistent. The client sends a write request to the leader. The leader does not execute it immediately. It first appends the operation to its log as a pending entry. The leader then sends this log entry to all followers. Followers append it to their own logs and reply with an acknowledgement. Once a majority 3 of 5 acknowledge receipt, the leader marks the entry as committed and notifies followers to commit. The essence of Raft is log replication. The leader periodically sends a heartbeat to all followers. As long as heartbeats arrive, followers know the leader is alive and will not trigger an election. Each follower maintains a randomized election timeout. If no heartbeat arrives before timeout, it concludes the leader has failed. The only trigger for an election. Raft uses randomized timeouts to prevent multiple nodes from starting elections simultaneously. Suddenly, the leader crashes. Heartbeats stop. All followers fall silent. They start waiting as their randomized countdown timers tick. The first node to time out promotes itself to candidate, increments its term number, and sends a vote request to every other node in the cluster. The candidate counts its own vote plus votes from F1 and F2, 3 votes, a majority, and is elected the new leader. The entire election completes in milliseconds, and the cluster resumes normal operation. 3 of 5 servers are online, 2 are down. 3 exceeds half. Raft calls this a quorum. As long as quorum is met, the cluster can continue to serve requests without losing data. 1 more server goes down. Only 2 remain online. Without a majority, the cluster cannot reach consensus and proactively rejects all writes. This is intentional. It prevents split brain and ensures data never diverges into conflicting versions. Raft requires only a majority, not all nodes. A 5-node cluster tolerates 2 failures. A 3-node cluster tolerates 1. This is the mathematical foundation of high availability in distributed systems. Raft's 3 core rules. The leader handles all writes. A log entry must be replicated to a majority before commit. If the leader fails, vote for a new one. This is Raft, using votes to bring consensus to a chaotic distributed world. etcd, TIKV, and CockroachDB all run the Internet's data on this exact foundation.